Question related to electricity and magnetism. Okay.
Electricity, right? Which one is this? Electricity.
This is block 4, classified paper,
Page number?
page number 49.
Sir, can you send it on the group?
The file again?
Yes. 8 of them.
Okay, wait, I will send this file again.
8 of them. Come on, come on. 8 of we are the page. दोनों को भेज दे भाई दोनों भेज दे एक तो मुझे दूसरा भेज दे है कभी रूल
Topic 4.2 to 4.4 electricity questions. We just discussed this in the beginning of a session that electric field is a region around a charge where its force can be felt. And what is the direction of the electric field? Direction of the electric field is a direction on the force on the positive charge. Like where the positive charge experience a force, we call that as direction of direction of a force on a positive charge is a standard term whenever they ask. Figure 11.1 shows a positively charged sphere. What we have to do on a figure 11.1, draw the pattern of electric field. Because it's a positive charge sphere, so we have to draw, because if a positive charge is placed nearby, it will move away. So what is the direction of the direction of the electric field? So the direction of the electric field will be out. So it's always out from positive and into negative. The spacing between the lines shows the strength of the electric field. If the lines, minimum, they said 5 is enough, but the spacing between the lines shows the strength of a magnetic field. If the lines are closely spaced, means stronger field, and if the lines have a large space between them, it is getting weaker as we move away. Like this point, the lines are closer, but at this point, the lines have large spacing. So, and it is obvious that as we move away from the charge, the strength of electric field will also decrease. The next is the charge on the sphere is 2 exponent negative 5 coulomb. That's the charge. A high resistance wire is now connected between the sphere and the earth, and it takes 20 minutes for the charge to flow and to become completely discharged through the wire. Suggest why there is a current in the wire between the sphere and the earth. Like we have the sphere. What we did, the charge on the sphere with the high resistance wire is connected. Like we connect a wire between the sphere and the earth that is connected to the earth. The question is why there is a current, why there is a flow of the charges. Charges will only flow if there is a difference in the voltage or the potential difference. Like here charges have, the question is why there is a current. Current is the flow of the charges. And current will only, like charges will only move if there is a difference in the potential. What is the voltage or the potential of the earth? We call earth is at zero potential. Let's say this was at 10 volts. Is there any potential difference between the sphere and the earth? If there's a potential difference, then the charges start to move. What if there was no potential difference? Like this was having 10 volts and earth was having 10 volt. Will there be a current? No current. Because current only flow if there is a difference in the potential. So why there is a current between the sphere and the earth? That is due to the difference in the potential between the earth and the charged sphere.
So if they have the same potential difference, then what happens?
If they have the same potential, then there will be no movement of the charges. Like if you have like two wires are there, one is carrying, let's say, 10 volts, another is also carrying 10 volts, and you hold them or you connect them by another wire. Any charges will flow?
Yes.
No. The charges always flow because of the difference in the potential. If they like difference in energy. If I say the simple way to understand this, if I have one box and I'm applying a force of 10 Newton towards right and 10 Newton toward left, will it move? No, it won't move. So same thing happened with the potential. Potential is work done on a unit charge, or it is like energy used to move the charge in the circuit. So if I have a difference here, if this was 10 volts and let's say this is 90 volts, is there a potential difference? Yes.
Yes.
And
Yes.
now the charges will move. How the charges will move? So it will always move from higher potential to the lower potential. So the reason for that one, that because there's a difference in the potential between the earth and the sphere, that's why the charges start to move. So difference in the potential, difference in the voltage is always responsible for the motion of the charges. So if let's say there's a live wire and you're holding a live wire and hanging on the live wire, will you get electric shock?
Yes.
No, because there's no difference in the potential. If you're holding a live wire and you don't have any other contact, you won't get an electric shock. Why? Because there's no difference in the potential. But if you're holding a live wire and you're touching the ground, will the current passes through you? Yes, it will pass and you will get an electric shock. So for the charges to move, there must be a difference in the potential. If there is no difference in potential, charges won't move. This is what happened in a battery. Like if I have a lamp and I have a battery. So battery is having difference in potential. Like this positive one is high potential. Let's say this is 10 volts. The negative one is zero potential. Because there's a difference in the potential, that's why the charges start to move in the circuit. Is it clear?
Yes.
Yes.
What if we hold a live wire and you contact with the ground, but the potential is very small? Will you still get a shock? Yes. If there's a difference in the potential, you will get an electric shock. If you are holding a live wire and you're touching a ground, even if there's a small difference in the potential, you will get it. But if the current is too low, you won't feel that shock. It will be a mild shock. But there will, if there's a difference in potential, you will always get a shock. Mild will be there, not dangerous, but yes. So if we have, let's say we have the two batteries. We have two batteries, 3 volts. So this is 3, this one is 0, okay? This is 3, this one is 0, positive and negative. Will there be a current in this circuit? Yes or no? No. Why no? Because see, what is the potential here? 3. What is the potential here? Any difference in the potential? No, because this battery want to transfer the charge. This also want to transfer the charge. Though both have the same capability to transfer the charge. That's why it won't work. The lamp will not light up. But we have, let's say, like this. So this is, say, let's say 4 volts and this is 2 volts. So this, is there a difference in potential? Yes. So the charges start to move. So due to the difference in the potential or a voltage, the charges always move in the circuit. Next is the average current in the wire. If you need the current, so to find the current is the rate of flow of the charges, the charge divided by time. How much the charge flow in the circuit?
2 multiplied by 10 power minus 5.
The current is charge divided by time. So we have the charge which is 2 into 10 to the power minus 5. And the time is 20 minutes. We have to convert time into second. So it will be 20 multiplied by 60. So 1200. 1000. 1200. What's the final answer?
1 6 multiplied by 10 power minus 8.
Minus 8 ampere. So this will be the current. Clear? Another question related to the electricity. Figure 9.1 shows a circuit with a 1.5V cell. Like there are 3 cells. This is positive, negative, positive, negative, positive, negative. Each cell is 1.5. What will the total? 3. Wrong. 3 cells are there.
Three cell. So what?
4.5.
4.5.
4.5.
4.5. Because each cell is 1.5. There are 3 of them, so total will be 1.5. So it means the total potential or a voltage will be 1.5. Clear?
Okay, yeah.
The total of this all. Now, no, total is for individual it's 1.5, but the total is 4.5. 1.5 plus 1.5 plus 1.5. So total is 4.5 volts. Now the charges start to move. How much energy they are connected in parallel? What is the combination? What is a characteristic of the parallel circuits? Whenever circuit is parallel, they will have the same potential difference as the battery. The current will divide between the component. And if I want to find the combined resistance of the two in parallel, it will be the product divided by the sum. These are the characteristic of the parallel circuit. They will have the same potential. The current will divide and the total resistance will be the product divided by the sum. When the current will divide, which resistor will have a high current? 3 ohm or a 6 ohm? Which resistor
3
will have
ohm.
a
3
3 ohm? Because low resistance, high current. Resistance and current are inversely proportional. So the component which is having a low resistance will have a high current. So when the charges will move from here, most of the charges will move through 3 ohm and few of the charges will move through 6 ohm. And then again it will recombine and that will flow. If I say the potential here, if the total is 4.5, how much potential here? How much potential difference? 4.5. What is the potential difference here? 4.5. Same, because whenever components are connected in parallel, they will receive the same potential difference. But if they're connected in series, the potential difference will be divided, current will be same, and the resistance will be the sum of individual resistance. This is a parallel circuit. Now the question is, calculate the total electromotive force, EMF of the cell. What will the EMF of the cell? Each cell is 1.5 and we need the total of the three. So 3 multiplied by 1.5, we directly write 4.5. 4.5. The next is total resistance. How to get the total resistance in parallel?
product divided by sum.
Like 3 multiplied by 6 divided by
2
3.
into
Yeah, so it's a product divided by sum.
2 ohm.
So R1 multiplied by R2 divided by R1 plus R2. So it will be 3 multiplied by 6 divided by 3 plus 6. 3 multiplied by 6 is 18 and 3 plus 6 is 9. 18 divided by 9, what we'll get? We'll get 2 ohm. So when two resistors are connected in parallel, it's always the product divided by sum. Okay, copy. So that is the total resistance of the circuit. Done. Next part, we need the current in the 3 ohm. First, as we know, the EMF of the battery is 4.5 and we know the potential difference is 4.5 here and the potential difference is also 4.5. We need the current here. How to find the current? We have the resistance. We have the resistance and we have the voltage. How to find the current if I have resistance and voltage?
V over R.
So the Ohm's law, V equals IR. Like voltage is current multiplied by resistance. This formula for almost all the questions of electricity you use. So it's a very important formula, V equals IR, where V is the voltage, which is 4.5. I is the current, we don't know. And R is the resistance of this component, that is 3. 3 is multiplied here, other side will be divided. So 4.5 divided by 3, what we will get? 4.5 divided by 3, so we'll get 1.5 and the unit will be ampere. So how much current will flow here? The current which will flow, that is 1.5 ampere. Clear?
Yes, sir.
So we have the resistance and we have the voltage. So we take the ratio between a voltage and a resistance to work out the current. Next is state using a letter in a figure 9.1. How would you connect an ammeter to measure the total current in the circuit? If I need the current in the circuit, where I should connect an ammeter between the two?
A to B,
Where I should, good. I can say A to B or
B to A. No, H to G. I think H to G.
H to G also. Anyone you can say. A to B, I can connect because the question is using the letters you have to tell. So we'll connect an ammeter between A and B.
So we have to draw.
No, we don't have to draw. We don't have to draw. They did not ask to draw. They just asked
We have to just.
state using a letters in the figure 9.1, how would you connect an ammeter to measure? So we'll connect an ammeter in series between A and B or G and H.
We have to mention both or one? One.
Anyone. Like either you mention A to B in series between A and B or in series between G and H. Then volt, what? You have to say, right, like connect ammeter in parallel, in series between A to B or G to H. A voltmeter to measure a potential across 6 ohm. I want to measure a voltage here across 6 ohm. So where,
To the
So-
resistor.
so I can connect between EF, even I can connect between GH as well. Sorry, BG. No, that will give, because they have the same voltage. They are in parallel. If this is 4.5, this is 4.5, this will also be 4.5. Because in parallel, the voltage is same. Even I can also say AH as well.
Okay.
They all have the same voltage. So I can connect in parallel between AH, or even I can say between CD as well. It's also right.
E.
EG.
No, what's that? Yeah. E.
Yeah, this will also work the same way. So voltmeter, is it possible to resistance? Is it possible to make a resistance? Yes, resistance can be a measuring tool. Resistance thermometers are there. Resistance sensors, like sensors are also there, light sensor and heat sensor. It uses a resistance as a property to measure. So you can connect a voltmeter in parallel between AH. You can connect in parallel between CD. You can connect in parallel between BG. You can connect in parallel between EF. All are suitable. It does not make any difference to any part. This is related to topic 4.5, electromagnetic effect. Draw a circuit symbol of a diode.
Triangle with a line going through it.
For B1, ammeter, you connect an ammeter in series between AB or GH. The answer for B1. Topic 4.5, electromagnetic effect. So we have to draw a circuit symbol of a diode. So a triangle will be there and a line. This is a diode. But what if they say draw a circuit symbol for LED? How I will change this?
So we will write the
Arrows. This will be
And outwards.
draw arrow outward. That will be LED. If they say draw photodiode, what?
What is it from a
Light emitting diode. When it work the same principle, but emit out light when the current is passing through it. What is the function of LED? Well, sorry, what is the function of a diode?
Current flow in one direction.
Yeah, allow current to flow in one direction, or we can also say rectifying. Rectifying means it convert AC to DC. No, rectifying means converting AC to DC. Diode is used as a rectifier. Figure 10.1 shows a proposed system for a charging the battery of an electric toothbrush. This is the battery is there. Handle of the brush. A coil X is there and a coil Y is there. It use the electromagnetic induction. I'll explain the principle, working principle. What will happen? Look, when there's a AC input, this what it produce? AC input produce changing magnetic field. When it produce a changing magnetic field, there's no connection between X and Y. Like there's no connection of the battery, but because of a changing magnetic field, the current start to produce in X, coil X. And that current we supply to the battery. But a battery want a DC, so we need a diode. So we have to connect a diode here. Because a diode will allow only one way to pass, another way it does not allow it to pass.
Pass.
Clear? So the working principle is the changing magnetic field of a coil Y, AC input in the coil Y produce changing magnetic field, change in the magnetic field produce a current in X. And then the current in X will also be an AC. How we can convert that AC to DC by connecting a diode. That is the working principle. Now we'll answer the questions. If you connect a diode on the other wire, if you connect a diode on the other wire, the direction of a diode, with like example here, we want a current to flow in this way. According to the question, we want a current to go in and this is the direction. So if I connect a diode other way around, I can connect in this way. This is fine. But if I connect the diode like in this manner, then it will be wrong. Why? Because the diode will not allow this will be wrong. Because the diode will block the current. So I can connect the diode, any one of them, but we want the current to flow. That's why either a diode connected in this manner or a diode connected other way around. But if you connect a diode like the line there, then it will be wrong. Why? Because it will block that current to flow. We want the diode to allow that current to flow. Now, actually, for a battery, charging and a discharging of a battery happen in a different manner. So the arrow here, what they pointed, these arrows are a reference point. They should not show this positive and negative to you. That is what you're confused with. So they should just give us that this is the direction of the current we want. So we connect from B and when we connected from A. This is the direction of the current we want to flow. So if I want a direction of a current to flow in this way, because if a current is coming from the side of the triangle, the diode will allow that current to pass. But if the current is from the side of the line, it will block that current. So we want the current to flow in this way. That's why I connected a diode in this manner. Or I can connect a diode other way around. So like both wires, we can connect this. So this positive and negative, maybe you're confused with that because if it's a positive, the current should be out. So it should not be there. That's why it is creating a confusion. But there's a reason behind that. Like it is for when the battery discharge, it will discharge in opposite way. That's why they give a positive and negative. No, this is the charging current. The charging and the discharging currents are opposite in directions. When you charge something, the current flow is different as compared to when you discharge. So they are right in terms of the concept, but the diagram, you're confused with the diagram because if it's a positive, the current should be out. And if it's a negative, the current should be in. But because they represent it's a charging, so for charging, the current is always opposite. For LED, does the color of a light emitting diode depends on... No, color of a light emitting diode. The color of a light emitting diode depends on the element which are present. Like which element, what is the impurity present when we manufacture a diode, that will decide the color rather than the current. It's not the current decide, it's the composition of a diode decide what color it will emit out. So this is the handle of a brush contain a battery and a coil. The circuit of a coil from coil X to the battery is not shown. The base of a charger contain a coil Y, which is turned on an iron core and connected to a AC main supply. To charge the battery, the handle is lowered so that the coil X coil Y is inside coil X. As you can see, like when we are charging, maybe you have seen this. Chargers are there for like trimmers, this electric toothbrushes, the charger. Yeah, so this is the same thing. Figure 10.1 shows the direction needed to charge the current in the battery. Like here, which direction we want the charging current, that is shown. On a figure, complete the circuit from a terminal A to B of a coil X to the battery, include a diode. Look, as I mentioned, what is a working principle? AC input, alternating current input produce variable magnetic field, and this magnetic field will pass through the coil X, and there's a change in magnetic field which produces a current. We want a current, so we connect a terminal here, but we want a current to move in this way or a current in this way. This is the direction of the current. So how I should connect a diode? I want a diode to allow the current to flow in this way. That's why I was making a triangle here and a line in this side. Or I put a triangle here and the line. Any one place you can draw.
The terminal should be out, right?
What?
The terminal should be out.
Which terminal should be out?
Should-
No, means because the diode, we want a diode to conduct. So the current should move from the side of a triangle. If we connect a diode other way around and the current is in different direction, then it will block the current. That's why we connect so that it allow the current to move in this way. It allow the current to move in this way. This is the charging current which we want. Okay. Don't be confused with this positive and negative, because like actually practical circuit charging and discharging currents are always opposite direction. We want a charging current. When it will discharge, like example, when this electric toothbrush is removed, then the current will move from positive to negative, other way around. Yes? Electrical to kinetic. DC motor. Yes?
We don't include that and we'll lose both marks.
No, you will lose one mark. Explain how an alternating voltage is produced in coil X. It's a working of a transformer. So what is the working principle here? The AC input. Is it possible to change the direction of a diode while the current passes through it? Now, if you change the direction of the current of a diode, then there will be no current. Like we want the current to move in this way. Okay. Let's say you connect a diode other way around. Will it work?
No.
No, it won't work.
Because
Why?
it's blocking it.
Because this will block the charges to flow.
Yes.
So conventional current cannot move. That's why the position in which the diode is connected, that is also correct. That should be correct as well. So the working principle, AC current, instead of saying a primary coil, you change. Look, this is right. The explanation is correct. But now instead of using a primary coil and a secondary coil, they use coil Y and X. So you just change your question. You will say alternating current in a coil Y create alternating current in Y coil, alternating magnetic field at the end. So instead of primary, we say Y. Which will magnetize the core and induce current in the coil X. The transformer. Yeah, actually this is a transformer work on the same principle, that when two coils are there, one is having AC supply, another one does not have anything, it produces a voltage. Wireless chargers also work on the same principle, electromagnetic induction. Like this is called mutual induction. Like one coil produces a current in another or a voltage in another. So changing magnetic field of a coil Y produces, like alternating current in the coil Y produces changing magnetic field, and change in the magnetic field induces EMF in the coil X. Okay? Clear? So alternating current in Y coil, alternating magnetic field at the end of a Y coil, alternating current in the not current, it should be alternating magnetic field in the soft iron core, which induces EMF in the X. Change in AC input. What, you want to copy that?
Yes, sir.
We are not copying them.
So write in your own words. That's a copy the answer from student. One of the student write that this answer. I just copied and I just.
We are students, so we are writing in our own words, student words.
The next is figure 9.1 shows a symbol of a battery, a 12-volt battery. Two lamps are connected in parallel with the battery on the figure 9.1. Use a correct symbol. So two lamps are connected in parallel. One of the lamp has a resistance of 6 ohm. Calculate for this lamp the current. Look, if it's a 12-volt supply, this is again a parallel circuit. When we have a parallel circuit, what are the characteristic of the parallel circuit? The characteristic of the parallel circuit, it will have a same potential difference. What will happen to the current? Current will not half, it divide. It might divide evenly or uneven depending on the resistance. If the two are identical, then it will divide evenly. And what about the resistance? If I need the total resistance, it will be the product divided by the sum. Okay. One of these lamp has a resistance of 6 ohm. So what is the voltage? If it's a 12-volt supply, this will be 12. This will also be 12. How much is the current? The question is, what is the current? So V equals IR. Resistance is given, 6 ohm resistor. So 12 is the voltage. So 12 is the voltage, current we don't know, and the resistance is 6. So how much? 12 divided by 6, that is equals to 2 ampere. So the current here is 2 amps. You wrote plus on the both side of the formula. Yeah, this is a product divided by sum. R1 multiplied by R2 divided by R1 plus R2. The next is the power. How to work out the power? Power is work divided by time, but electricity, because we have, three formulas of the power are possible. You can use P is equals to VI. You can use P is equals to I square R. And you can use P is equals to V square over R, depending on the question, what you have. But luckily in this question, you have all of them. You have the voltage, you have the resistance, and you have the current. So any formula I use, I will get the same answer. Let's say I use the first formula, P equals VI. So voltage is 12 and the current is 2, so I will get 24 watt. Another student use a formula of the power I square R. So I is what? It's 2 square multiplied by 6. 2 square is 4. 4 multiplied by 6, again you will get 24. Another student use a formula of the power P is equals to V square over R. So 12 square is 144 and divided by 6.
24.
So you'll again get 24. So if you have all, like any formula of the power will work depending on the question. But in this question, we have all voltage, current and resistance. That's why P equals VI, P equals V square over R, or P is equals to I square R, all will work.
Right?
So 24 watt is the power. Any formula you can use. The next is the power of other lamp is 36 watt. Total energy delivered by this lamp in 20 hours. Yeah, now you can use, look, energy is power multiplied by time, but electrical energy we consume a lot. So joules is a right unit for energy, any form of energy. But for electrical energy, we prefer to use kilowatt hour. Okay? Kilowatt hour. So when we represent the power in kilowatt and we represent the time in hour, we call kilowatt hour. So 36 watt, how much in kilowatt?
36. 6 kilowatts.
36 divided by 1000, so 0.036.
36,000.
No, divide. Divide. So 0.036. And the time is 20. What's the answer here? 0.036. Multiply. Energy is power multiplied by time. The power is 0.036 and the time is 20. How much? So 0.72 kilowatt hour. And 1 kilowatt hour is refers to 1 unit of electricity. Because whenever we consume 1 kilowatt hour, we say we consume 1 unit of electricity. It's even less than 1 unit. So the cost of the answer in, because the answer can be in joules. It's not wrong. Answer can be in joules as well. But usually for electricity questions, work out the answer in kilowatt hour for electricity. Okay.
But the answer.
I know this is because it's from the past paper, which was before 2023. Yeah, sure.